Hi. In this presentation, I will present and summarize our paper, The Companies Reveal Their Own Fraud, where we, among other things, mainly provide an open source dataset that can be utilized for fraud research. So, according to the Association of Certified Fraud Examiners, the most effective way to uncover fraud so far is through tips. Nevertheless, rule-based systems have the potential to be effective in uncovering fraud, especially if they're used as a crutch for fraud examiners to lean on. Fraud is also a very broad term and can be sliced and diced in several different ways. So for the purposes of this research, we focused on occupational fraud and its subcategories: asset misappropriation, corruption, and financial statement fraud. The most relevant regulatory body when it comes to fraud in the US is the Securities and Exchange Commission, in short SEC, whose purpose is to enforce transparency in financial markets. It does so, among other things, by requiring periodic reports from public companies and by publishing its legal actions against fraudulent firms and individuals through accounting and auditing enforcement releases, in short, AAERs. So the goal of the research became to try and classify a firm as fraudulent or not using the management's discussion and analysis section of 10K findings. But some issues were clear from the outset. First of all, fraudulent data suffers from high-class imbalance. There might be temporal effects at play with the evolution of language and corporate culture, and assuming that all fraud is caught is utopic. Hence, assuming that the problem might be a positive unlabeled one instead of a classic binary classification problem might be more fitting. The reason we chose to classify fraud using the MD&A section is based on prior research on financial disclosure that concludes that fraudulent behavior can be linked to management's disclosure. Especially the work of Lewis and Hoberg served as an inspiration for this project, also because it's a bit dated and could use especially a methodological update. Bhattacharya and Michkovich's work served as a more modern methodological crutch to lean on. So the actual contribution of this research was not something intentionally designed, but rather a hurdle we faced and needed to overcome. When setting out to achieve our goal, we couldn't find open source data to try and answer this question. So we thought, why not try and create our own data set by scraping it from the internet? Thankfully, the SEC provides public access and maintains the Electronic Data Gathering, Analysis, and Retrieval database, which contains all filings submitted to the SEC. And using the Scrapy library and the publicly available CIK list on the SEC's website, we designed a scraper that navigated through all the yearly filings of the companies listed in the CIK list. From all the filings, we extracted the highlighted metadata contained in the filing header, which is standard across filings. But the challenge was then parsing the documents to extract just the MD&A section. We eventually ended up using the SEC API software to standardize extraction. And we subsequently labeled the data using the AAERs posted on the SEC's website, which are not contained in Edgar. The problem with the AAERs not being part of Edgar was primarily that the list was not exhaustive, and fraud cases are rare as it is. Moreover, the AAERs are even more diverse in format than the 10K filings. They are often vague in their mention of the fraud period and sometimes inconsistent in naming the companies. So we ended up applying heuristics to infer fraud periods, to determine fraud types, resolve CIK discrepancies, and filter ambiguous or incomplete cases. The compilation of the input data and the labels were two separate processes that we mapped to each other using the company CIK. The labels dataset contains information such as firm identifiers, estimated start and end dates of fraudulent activity, certainty indicators for fraud period boundaries, applicable legal violations, and the ACFE categorization of fraud. Now, all the labeling and scraping we did resulted in two separate datasets that had to be merged. First of all, the labels dataset containing information of fraudulent activity, and the second one was the firm year dataset containing all firm years with their respective MD&A disclosures. We merged both using the CIKs and labeled the firm year as fraudulent when there was an overlap between the reporting date and the fraud period. The result was a dataset containing about 90,000 firm years with 57 variables across roughly 5,000 firms. However, from a textual analysis standpoint, we still had to do some filtering because not all MD&As in the dataset were substantive. And the scraped data contained all types of yearly reports, some of which had to be excluded for the purposes of fraud classification. So the filtering criteria we settled upon were first removing all MD&As containing 200 words or fewer, and excluding all amended yearly filings to all yearly filings with the suffix /a. And the result was a data set with about 70,000 observations, representing filings with substantive disclosures. Now, the large unfiltered data set contains about 5,000 companies, spans 33 years, and has a median of 13 filings per firm. One thing to note about the number of filings in the unfiltered data set is that it sometimes contains several filings for a single period, mainly because of the amended filings still contained in it. The dataset contains firms located in 2,157 cities across all 50 US states, Washington, D.C., and 3 US territories. The total coverage includes 158 unique jurisdictions, including Canada and offshore regions, and there are 91 jurisdictions of legal incorporation in the dataset. If we look at industry based on SIC codes, the dataset spans 412 industries, the most common being pharmaceutical preparations with about 5,000 firms. And if we go one SIC categorization level higher, the most frequent major group is chemicals and allied products, and the top division is manufacturing. However, it's important to note that the SIC code scraped from the metadata in the yearly filings contain errors and inconsistencies. The ones we found were corrected, but it's likely that some still remain in the scraped data. In terms of the input text, the length of the MD&As increases over time, likely due to improved standardization of the SEC documents, which makes it easier for the software to parse yearly filings. When comparing the fraud distribution in the large and in the smaller filtered dataset, the fraction of fraudulent firm years declines from 2.9% to 2.3%. And one thing particularly relevant for textual analysis is that MD&As vary widely in their length. The number of fraudulent filings and their distribution over time show peaks consistent with general economic trends, most notably around the dot-com bubble and the housing crisis. It decreases more recently, largely due to regulatory lag in fraud detection and the inherent difficulty in determining fraudulent behavior. In the dataset, the average delay from the start of a fraud to its detection is about 6.5 years, and the average delay after the fraud ends is about 3.5 years. The average duration of a fraud is roughly 3 years, and most firms that engage in fraud engage in financial statement fraud, and nearly all cases of asset misappropriation are coupled with financial statement fraud. And finally, based on the enforcement releases, it appears to be easier to determine the beginning of a fraud than its end. Now, using this data, we were able to pursue our original goal of predicting fraud based on disclosures. We ran all experiments using a forward chaining design and evaluated the models using the macro F1 score because of the dataset's class imbalance. All experiments were compared against a baseline model trained only on the metadata scraped from the filings, and all models were tested on the same year, the year 2011. The experiments we ran can be classified into 3 modeling families. First, tabular models trained using random forest and XGBoost, text-based model using BERT-based architectures, and topic models using latent Dirichlet allocation with different numbers of topics. This was inspired by the work of Lewis and Holberg. And as you can see, especially based on the macro F1 score, no model was able to outperform the tabular baseline. Now, there is definitely room for improvement in trying to predict fraud based on MD&As. The experiments we ran were by no means very complex, but our main limitation was time. We wanted to merge both textual and tabular data using CompuStat. We also had modeling constraints, mainly due to limited computing power, which restricted the types of models we could utilize and forced us to truncate the texts. We also would have benefited greatly, I think, from working with domain experts on fraud to better assess factors like temporal drift or the number of topics we could have selected when using LDA. So the lessons learned or recommendations for future work would be to maybe try and integrate tabular and textual data, to use rolling windows to better capture the evolution of disclosure language, to maybe consider modeling the problem within a positive unlabeled framework. And if you have sufficient compute resources, experiment with generative models to pre-process mDNAs, especially since they're very long. And finally, don't forget to keep interpretability in mind, especially for regulatory applications. That's it from my part. Thank you for the time. Please feel free to use our data. And if you have any questions on our data sets, then also please feel free to contact me on my personal email. And thank you.